Good morning, everyone. Welcome to another episode of Xa Talk Show. How are you guys? So we are going to do Wolfram language coding. We are going to continue from yesterday's George's Wolfram language code that does Unix grep, that is find text in all files in a directory recursively, including subdirectories. So video check and audio check. Let's see. Video check, audio check. Am I streaming? Yes. Okay, let's go. We are ready to go. Good morning, Andrew. So Wolfram language coding. So I'm going to go through George's Wolfram language code, and I'm going to optimize it. Now, it's easy when you have already a code. You are just going to modify it. George, so let's give, so George did great. He wrote this, he's new to Wolfram language, and he wrote this find string script. But because I've been coding Wolfram language for 10 years, so I can optimize it, make it idiomatic, and improve it. So I think there's a lot to do today, and so I'm going to teach you Wolfram language, some of the tips in Wolfram language about efficiency and all that. Efficiency, okay, so let me tell you what's the steps we are going to go through today. So first of all, I'm going to go through the syntax, change the syntax to a better, faster form, okay? Then the second thing I'm going to do is to change the algorithm. So the result should be a magnitude faster. So the result should be a magnitude faster, okay? So here's a script. Okay, so let's begin. So today is 2021, November 9th, okay? If you have common questions, good morning, Alan. Good morning, Alan and Andrew. So comment and questions posted. Love to see them, okay? So let's do Wolfram language, okay? So let me start Wolfram. Let me start the Wolfram code. I mean the Wolfram desktop, the Mathematica. So a new one, and 1 plus 2, evaluate 3. That's good. Let's put this window here. Now, so you can also see my keyboard. This is, this video, this is Kinesis Advantage 2 red switches. This is Ultimate Hacking. You go to search for Xali keyboard and go buy it. I have full reviews and video and all that. And okay, so that's how I operate a computer. You see, I don't press any keys, but I can switch windows. I talked about this many times. This is the very efficient way, as opposed to the Control tab, wait, where is the control? Alt tab, the Alt tab. Oops, which one is it? That's silly. So you see mouse operation. Now, can I see myself? Yes, you see, yeah, you can see my mouse. So now, let's rid of that, and let's begin, okay? Let's begin to the code, okay? So, I'm using Safari keys in Emacs, and I'm using Vorak keyboard. So you can see here's a code. Now let's change the file name, okay? So let's change the file name. So let's say wgrep, okay? Okay, that's a file name, wgrep. Let's magnify and hide the, and delete the temp files. So here's a file, and open it. Make a backup, go to the directory, refresh. You see, this is a backup file. And now let's change it. wgrep 1, wgrep 2. Okay, let's name it that. So right now, these two are identical files. Now, so the original, I'm going to modify the original, and I'm going to modify the wgrep 2. So, but first of all, okay, open this and go to the PowerShell, one key press. We are to the PowerShell, Windows PowerShell. And first of all, we want to test the script works. Okay, so let's so Wolfram script file wgrep1, and you need to give a pattern. So what do we want to find? Let's say we want to find Haskell. Okay, and what directory? The current directory. Okay, enter. So that prints. Let me magnify. So that prints every occurrence of lines that contains the word Haskell. So this is George's script. So you can see here's the word Haskell. First of all, it prints the file name. So in the file topic notes.html, so you have this one occurrence, Haskell syntax sucks. Why Haskell syntax sucks? And so each line, when it occurs, you print it, but before you print the line number. So for example, if we go to topic notes, the file, and line 401, we should see it. So let's go to open topic notes and go to line 401. So 401, wait, so what? Oh, 401, not 410. So 401. So there it is. So you can see Lang design, formal languages, complexities of grammar, syntax algebra. Why Haskell Lang syntax sucks? So there it is. Indeed, it found it. Close it. So you see, for each occurrence, if it occurs in a file, first of all, print the file name. Then for each line it occurs, print the line and also print the line number, and repeat for every file. So this is the what the script does. Okay. Now let's begin the modification. Okay. Let's open the wgrep2. We're gonna start to modify it. Okay. Now the first line is shebang. Shebang is a traditional Unix way to run a program without typing the interpreter. For example, we typed Wolfram script. That's a application that runs Wolfram language. Then we give option file. Then this is a script. Then the argument to the script. But alternatively, you don't have to. Because if you have the shebang line, you can just say, this becomes like a Unix program. You don't have to. Let's try it. Yeah. Okay, so hold on a second. So I think I got a space. Is that right? Yeah. Okay, so wait. Oh yeah, so you see, this line needs to be the first line. If it's on the second line, it doesn't work. It's called shebang. Okay, look it up. Shebang. This is a classic Unix stuff. Okay, so now let's save the file. You see, I don't ever press save in Emacs, because, for example, I changed something. You can see the asterisk here. That means the file has been changed. But however, whenever I switch window, you see it automatically saves. So I never press save. So that's another efficiency tip. And you can find the code in Emacs by just searching autosave, Xali Emacs autosave. You can find out how to do that. So that's an Emacs tip. Okay, so anyway, so back to the script. Let's do the shebang. Hey, wait, why is it... the shebang is not working. Oh yeah, that's why. That's the reason the shebang line is not working, because I'm not on Unix. I'm on Windows. Windows doesn't know what the fuck is the shebang. So you have to do it this way, okay? Which I prefer. The shebang line is a crime. It's not a good design. The Unix fuckheads, they love this slant. It's a hack. Okay, it's an extreme hack. I would recommend, if you code in Perl, Ruby, Python, never use the fucking she line. Always have the full interpreter in front. Okay, because that's more functional. There's no implicit crap. You know exactly what you are running, not by magic. The magic line, magic line and magic characters. By the way, the first two characters, those are called magic characters. Okay. Okay, I'm ready to digress. Okay, not that. So I'm ready to digress, but I want to show you quickly, so you can see the Wikipedia, they talk about Shiban. Okay, no good. Don't use that. Okay, so anyway, so back to PowerShell. So I have 2 instances of PowerShell running, close that one. So, okay, so you can see now the script works. Wait, what happened? Okay, enter. Yeah, so the script works. So now we modify it, okay? So I'm going to modify it now. So on the pink window on the left, you can see all the commands I call in Emacs and all the keystrokes that corresponds to it. So for example, moving cursor and so on. So you can, once you know the function name, you can look it up. Most of my functions is on my website. Just search for it, you'll find it. Okay. So the Shiban line we don't need, okay? So, well, let's leave it, okay? So first of all, it assigns the executable. So, okay, this is gonna be a long session because if I'm going to explain everything, then it's gonna take a while, 1 hour. Let's see how long I've been, 16 minutes already. Okay, I'm going to try to do it fast, okay? So, first of all, we are going to optimize this program kind of by trivial syntactical way. Then we are going to change the algorithm. So the whole thing, right now you see it's like 20 lines or so. The whole thing should be one single line, and the result should be much faster. So, but first of all, let's go through a syntactical kind of make it faster by syntactical means, okay? So here you have the so the $ something, Wolfram language, every built-in symbol begin with a capital letter, okay? Or it begins with a $. So this is a built-in symbol, and we can look it up. So you can see script command line. Let's turn on JavaScript so we can see the details, okay? Comments. Hey, Dion. So you can see now. You can see, this is the documentation. So every built-in symbol in Wolfram language either start with a capital letter or start with a $. And by the way, there's no any other punctuation symbols. It's just pure English letters, except the $sign in front. So this is a built-in. Whenever it's a $sign something, that means it's a built-in variable. Or in PowerShell, the terminology is automatic variable. It's just a variable predefined. It has a meaning. So $script command line, which returns a list. Okay, I can just tell you what it returns. It returns a list of 3 things. Okay, the first thing is the program name. The second string. Okay, the second thing is arg1, okay? The second thing is arg1, the third thing is arg2, and so on. So it returns a list of, just like Unix $0, bash $0, $1, $2, and Perl, and also Ruby, because this bash, Perl, Ruby, they have the same lineage. So anyway, so that's that. So that's what this returns, okay? So command line, script command line that returns, the command name and arguments. Then what is this? This is gonna take a long time if I keep doing this. So this part, the double square brackets, that's a shorthand syntax for. So let me explain. Expression. And whenever you see this, that's a shorthand syntax for and, okay? So these 2 things are equivalent, syntactically equivalent. That means Wolfram language, whenever before it does anything, it changes all your, the whole source code. It transforms everything into a functional form. So this is a shorthand. This is the equivalent, 100% equivalent syntax, okay? So because Wolfram language, it just transforms everything like that, or the equal sign, or everything. So basically, in Wolfram language, it's just like a Lisp, okay? Everything should have this form. Let's magnify, okay? Everything should be A, B, C. Everything in the language should be this form and only. There's no equal sign, there's no band, there's no plus sign, there's no minus sign, nothing. Okay, this is important because as you learn more Wolfram language, this is a very important thing. I have a tutorial here, Wolfram language syntax. I explained. So anyway, just everything should be this form. Any of the A, B, C, or F should be nested, arbitrarily nested, just like Lisp, except Lisp use parentheses. And in Lisp, you put the F inside the parentheses. But in Wolfram language, this is the form, everything. There's no plus sign, there's nothing else. So but there are many shortcuts to Wolfram language, syntactical shortcuts built in, called meta expressions. So whenever Wolfram language, before it compiles, it transforms everything like that. For example, this equal sign. So for example, let me give you an example. This line, let me copy it. That line can be written as set executable to part, part, then that and 1. So this line, let me turn on the global highlight mode. So this line is 100% equivalent to that one. You see, so the second one is completely nested, syntax. Okay, I'm digressing. I don't want to talk about this. So today, I'm just trying to, optimize this code. So let's do it again. Okay, so executable. He assigns the executable file name, which is this file. wgrep2. That's what it returns. The first element of that, which is this command, this script's name. So this executable variable is used only once. You see, so we don't need it. Okay, so since it's only used once, let's just put it here. So and this part, so we have a if expression. If expression takes 3 arguments. The first argument is a test, so it tests if the length of the arguments plus a script is not equals to 3, then print the usage. Okay, that's what George says. But so if takes 3 arguments, so actually the proper code you should have a semicolon. So if takes 3 arguments, the first argument is a test. If it's less than 3 arguments, if it's not exactly 3 arguments, then print the usage. Then it runs the second argument. I mean So the first argument is that. The second argument is these 3 lines together. So if the test is false, if the test is not equals to 3, it is true, then you print usage. So so let me show you an example. So let's call this again. Let's magnify. Okay, so let's omit the directory path. Okay, you run it. It says usage. Script name pattern path. So this part is code. So that's what that is doing. Okay, so I need to go actually faster. So here the pattern. So this program takes a pattern. Has got what you want to search. So that is what this line does. Then the third argument is the file path. So which is dot, which is the current directory. Okay. Then so those lines are fine because pattern it's used multiple times. And so now let's do this one. Okay, so here this one is more complex. Let's so this line. So what? Okay, so this line is actually defining a function. Okay, so it defines the function add indices. The argument is a list. and the function is this map indexed function. Okay, so you can see the documentation map indexed. By the way, I'm using, I'm coding Wolfram language inside Emacs, and because I'm using, XA Wolfram mod. So if you like my stuff, buy it. Okay, so let me show you quickly. Press the key. So wait, press the key. Okay, so here's the source code. Here is the documentation for XA Wolfram mod. Open it, and you can see about 2,000 something lines in Emacs Lisp. And here is the beginning of the file, and you go to the URL, show in browser. So this is XA Wolfram mod. If you like it, if you interested in coding Wolfram language in Emacs, pay me. Okay, PayPal me. I tell you, PayPal me, and I send you. Okay, that's a Wolfram language mod. Okay, so close that. So close that. Yeah, close that. Close that. Okay, so back to this line. This is a function, and oh my God, to explain the whole thing will take an hour. So basically, here is a defining a function named add indices, and what it does is that it takes a list argument and well, the easiest way, let me explain. The easiest way is just actually run the code. Okay, so let's say x ABC. Okay, ABC. So you can see what it's doing. So I paste. So you see, this is a list ABC, and map index is just like map in normal languages, except you also give the indices as a second argument. So let's just run it. So you can see now ABC becomes 1A, 2B, 3C. So those numbers are the position or index of the each element. So that's what the map index do. And this part is just a shortcut for. This is a shortcut syntax for function. So this is a function that the #1 symbol means the first argument. The #2 symbol means the second argument. So it returns a list. You can see it returns a list where the first argument, the first element of the list is this thing. So that means take the first element of the second part, which is the index number. So, oh my God, to explain the whole thing is gonna take one more day. It's gonna take an hour. So any comments? So is script command line 1 indexed? No. Well, yes. Basically in Wolfram language, everything is 1 indexed, but it's a bit tricky. Okay, so it's a bit tricky, but you can see. Okay, so let's do this. Okay, so let's say, so here we want to write a function. Okay, so map index, the first argument is a function. So let's say, so the function, and let's say 2 arguments. Okay, so x and y. Okay. Then let's just say return themselves, x and y. So you run it, so you can see the map index map this function to the list ABC, and the result is this. Each one is A, then bracket 1. Why bracket? Because in Wolfram language, usually a list is usually arbitrarily nested. Unlike most other languages, Ruby, Python, Perl, JavaScript, typically, even in Lisp, typically the list is just flat, But in Wolfram language, it's like almost every expression is like arbitrarily nested list. So how do you give a index to arbitrary element in a nested list? Well, you give a list of indices. So if you have a flat list, then you just need an integer. 1 is the first element, 2 is the second element, and so on. But if you have a nested list, then you say you give several indices. The first index is the first level. Then for example, the first element, then the second element of that result, then the seventh element of that result. So several indices, which means take the element consecutively. So in general, any element in a tree, in an arbitrarily nested list, each element has a specific position. You don't call them index anymore, a position. So the position is a list of integers, just like this. So because now ABC is a flat tree, that's why you have just 1, 2, 3. But otherwise, so okay, so that's about the position of a list. Okay, so but so the question whether Wolfram language is 0 indexed or 1 indexed is a bit, in general, it's just 1 indexed, okay, 1 index, unlike other languages. Just like all mathematical languages, they are all 1 index. However, the 0th index refers to the head of expression. Okay, I'm digressing a big time, so let me show you. Okay, so okay, hold on a second. Let me show you what the whole deal is about the position, about the 0 index or the first index. So we don't want we want okay, let's use this position. Okay, so I'm going to show you x equals to a, b, c. Okay, except b is nested. Okay, b1, b2. Okay, so here we have a list. Okay, x is that kind of nested list. So now we use the function position. Okay, position, then you want to say position x. Okay, and what element you want to find? You want to find the element b1. I want to know what is the position of, let's say, a. Okay, show it. So that is the position of a, which is the first element. Okay, what about the position of b1? How do you you do that? So here's the position. So that means it's a second element, then the first element of that. So you see the second element, then the first element of that. Okay, so this is very interesting. Okay, yeah, but we're gonna continue. But what about zero? So what about part? Okay, so let me show you another thing. Okay, so let's say I want to take the part, the first element of the expression x. Okay, so that gives you a as expected. What if I say second element? That gives you b1 and b2 as expected. Third element is c, of course. Now what if you say 0? That's interesting. So when you say 0, it will actually return this whole thing's head, which means list. Okay, so you see, because why is that? Because let me show you the full form of x. So you see the expression we typed here, this list, a, b1, b1, c. The full syntax is actually this. So this is a general form of any expression in Wolfram language. Any, just like I mentioned before. So when you have this expression, a, the position of a is 1. The position of the second element is this thing, list b1, b2. And the third one is c. What about the index 0? So the index 0 refers to, you see, the head, which is this list. Okay, now this is kind of advanced, but it's very fundamental. If you program Wolfram language seriously, you have to know this. So that's about the index issue. In general, you don't, unless you become very advanced, you don't use the index 0. So it's very rare. It's very rare to have the need to extract the 0th element. Okay, so okay, I digress all the time. That's the nature of talk show. So let's go back to. So we showed the map indexed. So okay, I want to explain. So here, So here is a function that basically take the list as argument and returns the list with the index in front. Why do we need to do that? Because we are going to read a file and split all lines into a list. When we print lines of occurrence, we need to know the line number. So that's why this is doing add indices. So this function, this is definition of function, but there's a much better way to do it. So what this function does actually, you are actually looking at symbolic pattern matching. So this is a very common way to define a function, but actually the full form, let me show you what this actually is. So when you have something, okay, let's say 2. So what that means, the full form of that is actually this, okay, set delayed, okay, so let me type it x2. So this line is actually 100% equivalent to this line syntactically. So now with the full function name, you can actually now understand what it is doing. It's actually, when you do this x colon equals to something, it's actually creating a rule. It's telling Mathematica, it's telling Wolfram language that whenever the expression on the left-hand side occurs, replace it with the one on the right-hand side. You see, we are defining a rule to Wolfram language. So the left-hand side can be not just a symbol, it can be arbitrary expression. It can be like arbitrary. The right-hand side, again, can be arbitrary. So once you tell Wolfram language to set up this rule, set delayed, then whenever it runs computation, whenever it sees the left-hand side pattern, it will just replace it by right-hand side. So this is very interesting because you are seeing the Wolfram engine, how it does computation, a big part of it, that is symbolic pattern matching. So on the surface, this looks like, oh, you are just defining a function. That's correct. But however, the way the function works is very different from typical languages. It's actually defining a rule, replacement rule, symbolic pattern replacement rule. So here I explained this, x equals to 2. So what about this? What is this doing? So this is telling Wolfram language that whenever you see something, that says add indices, a symbol add indices followed by a bracket, then whatever inside. So that's a underscore, that means a blank, that means whatever. So add indices bracket whatever, can be 1,000 characters long, whatever pattern or list or whatever. So whenever it's telling Wolfram language, whenever you see that, replace it by that. Okay, that's what it's doing. Now, but using pattern matching is in general a lot slower. Pattern matching is very powerful. Especially when you do graphics, it's very powerful because without pattern matching, this is one single line, but sometimes for some occasions, for some task, without using pattern matching, you're gonna require 100 lines or more. So pattern matching is extremely powerful, but usually it's 10 times slower, very slow. So alternatively, we can define this function add indices without using pattern matching. So let me show you how to do that. Okay. So instead of doing that, so we okay, so let's delete that. Okay, so let's write this without pattern matching. Okay, so let me write it function list. Okay, so this is how you do it without pattern matching. You see that underscore, that means pattern matching, but here we don't have patterns at all. So what this one does, in fact, we can actually clarify this part too. So let's not use the shorthand function. Let's not use the shorthand. Let's write this way. Okay, xy okay, returns a list of two things. The first thing is y, and the second thing is x. Okay, so this part and this part are exactly the same. Well, not exactly, but it's getting details. But anyway, they are the same. Okay, so but the second part, you see, the first part, this line is kind of a shorthand. So the first time you code Wolfram language, you know, what the fuck is that? You don't know. But the second one, full form syntax, you know, it's easy to see what's it's doing. So it's a function. You know, this function is just like Lisp's lambda. Okay, so it's basically a lambda. So it takes two arguments, x and y, and the second argument is what it returns, the body of the lambda. So it returns a list. The first element is the first part of y, the second element is x. So that's what that is. So now we can compact the whole thing. So this line becomes that, okay, the add indices. So it's a function. So now we can comment out the first one. Now we can comment out the first one and go back to shell, and let's run it to check if it runs. Okay, so we are coding wgrep2, the new version. So it still works. So you can see these two are equivalent. Okay, so now we did this. Okay, so actually, so you see in this code there's a lot of pattern matching going on. So actually, so you can see, and you know, this underscore, whenever you see underscore, you know, that's a pattern matching. This is again pattern matching, and this is more complicated pattern matching. So this one, for example, this line is telling Wolfram language that remember the colon equal that says, you know, create a pattern, create a rule, such that whenever Wolfram language sees the left-hand side, replace it by the right-hand side. You know, so in a sense, in essence, it defines a function, but it needs not to be that way. So let me do another example of rewriting this without pattern matching. Okay. So you just so you just say that. Okay. So again, you say function here. Function takes two arguments. The first argument is parameters. The second argument is body. Okay. So the first argument is number and contents. Okay. So okay, so this is how you do. So this function and this function are kind of semantically equivalent, except this way of implementation does not require pattern matching. Okay, so let's comment out this. Let's comment out that line and run the code again. You see it runs. Actually, we screwed up something because the output is is different. What did I? Oh yeah. So wait. Okay. So yeah, I made a mistake. Oops. So you see this pattern. This function actually only have one argument. You see that list number content. That's actually one argument, it's not two arguments. So here our function is wrong. So it should be, let's just say x. Okay, so x is the argument. So, and the print the x, okay, the argument, then the first part of the argument, okay, then x the argument, okay, the second part of the argument. Okay, now comment out this line. Let's run it again. You see, now it works like before. So what I showed is that, you know, you can see, let's shrink a little bit. Let's shrink. So you can see these two lines are equivalent semantically. The same is a different way to implement same thing without pattern matching. Okay, now let's delete the first one. Now, likewise, we can rewrite each and every of these functions, but we are not going to. I'm not going to, because it takes, you know, because we have a lot of things to do. Okay, so we already, it's 44 minutes, 40 minutes already. We have a lot to do, actually. Wow. So let's see, what are we saying? So it's a good question. Yeah, some should sell video course. True, some listen to Dion. Sell video course. Well, thank you guys for donation, but that's kind of what I'm doing now. So, and other people who are not, who are watching my YouTube offline can donate. And also Wolfram Wolfram Incorporated, they are sponsored. They are sponsored by my videos. So I should say that. Okay, so let's continue. So what is the plan? So I'm going to, we do want to optimize the code. So let me just do quickly. Okay, I did the explanation. Now let me just rewrite these lines of code so that it does not use pattern matching, because pattern matching makes your code 10 times slower. So once we do that, then I'm going to rewrite the whole thing. Improve the whole code by using a different algorithm, because the whole thing, grep a bunch of files, only it should be one single line. Okay, so but let me quickly rewrite the patterns. Okay, so here we have text. So text add indices. So again, let me use the function form. So let me quickly rewrite this lines function by without pattern matching. Okay, so wait. So add indices. Now this add indices is actually just a function. So add indices, a function. So let's actually put that. So wait, what is this doing? Add indices. So okay, so let me explain what is this slash. Okay, so slash, whenever you have something like this, a/b, where a and b can be any expression. Okay, so that just means ba. Okay, so this is a, so the slash, so the slash b, a/b is a shorthand for this. So it just means call the function b with a as argument. So this is a postfix notation, just like the Unix pipe. Okay, the Unix vertical line. That's what this slash is. Okay, so let me, I want to quickly finish rewriting this so we can move on. Okay, so this is one way to do it. Okay, but that's kind of verbose. Wait. Okay, so wait. That's not right. I think this is okay. What are we doing? Split string. Split string. Okay, so let's. So this function mostly is going to split string, then so split string, given a text, a giant string, you want to split by returns, or line return, or the Windows convention or Unix convention. It returns a list. Then once you have a list, let's just do it. Then let's just do it in this way. There's a lot of ways to make this much shorter, but let's not worry about that. Let's just do it. Okay, so comment this out. Let's test it, see if it still works. No, it fucked. Where did I fuck up? what did I add indices? Which one is this? What is the operator precedence? I need to know. Yeah, okay, so the right hand side stays on the right hand side. Okay, so let's just do this. This is the argument. What? No, okay, so I can actually, oh yeah, text, that's why, text not lines. Yeah, so I got the, wait. So function, one argument, function of one argument, u, and the body is split string, okay? So yeah, then you want to add indices. So yeah, so this will be applied to the second part, okay? So it's gonna be like that. Yeah, so there, shrink. So delete, so this line and this line are the same. And further, we can, you see this function, you see, let me explain this, okay? So whenever you have function x body, whenever you have something like that, there's a shorthand. By the way, the full form is actually, so this is a function. So this is how you write a function, okay? So the function, the first takes two arguments. The first argument is a list of parameters. So you say a list, and it can be x, y, if you have two arguments, or z, three arguments, or a1, four arguments, and so on. The second part is body. In the body, whatever is the first part will be replaced in the body once you give it a argument such as 3, okay? Now, so this is the full form to define a function. Now, there's a shortcut. So because the list, whenever you have a list, there's a shorthand syntax, which is with the curly braces. That's a shorthand. So this line is exactly the same as this line. But however, we can shorten it further by hold on a second, let me, by shortening it further by just this, okay? By just that ampersand sign. How that works in a body, for every argument, to represent the first argument, you say #1 1. Okay, to represent the second argument, you say #1 2. So okay, so we are going to rewrite this function by a shorthand. So let's see. So first of all, remove that. Okay, so we're gonna rewrite this function by a shorthand. We don't need the argument text anymore. So just say pound means the first argument, and add a ampersand. So these two lines are again the same. Okay. Now, if you're just a beginning Wolfram language user, you don't have to worry about, because of this shorthand syntax is kind of cryptic, So if you just begin, you can just write everything in the full symbol name and square bracket. That makes it much easier to understand. But as you go on, the shorthand is extremely powerful because it compacts your code. So what I'm saying, so you are seeing, these two lines are identical. Okay, so these two lines are identical. And now we, since all these lines are identical, let's comment that out and comment. So we can see how the progression of of simplifying the code. So this line becomes this line. This line pattern matching becomes this line without pattern matching and becomes this line more abridged. So we can comment out the first one, back to PowerShell, run the code, run it, works as before. So now remove that. Okay, so now we also need to do this again. So this one, how long have I been talking? Is it boring? A structured course like the stuff on Khan Academy. We have time, carry on. Okay, so right now it's 1 hour already. Okay, so now I'm going to rewrite this line without pattern matching. Okay, so let me just go faster. So rewrite that line without pattern matching. So text is the argument. Where does text occur? So text occurs there. So what this does is okay, so it's calling select. Select takes 2 arguments. So select takes 2 arguments. Select basically select. The first argument is whatever expression you want to select for. It's a list. Okay. The second argument is a function that whenever the function returns true, then return it. So the select function in Wolfram language is like filter in Python or other languages. Okay. So it takes a list and a function, it returns. It kind of reduces the list only when the function returns true. So you can see here is using the shorthand for the function. So again, the full form for the function would be like this. Okay, the full form for the function would be actually x. The full form for the function would be that. Okay, so these two are kind of the same, but shit, what am I doing? I'm kind of like wasting. So let's finish this. So you want to select as a function. So yeah, okay, the easiest way is actually just okay. I'm kind of actually this will just work. Okay, so let's just put here and text. Okay, so function to argument. The easiest way to transform is this. Okay, so that will work. So this line, these 2 lines are equivalent. Okay, semantically, not syntactically, but semantically. The first one is using pattern matching. The second is without using pattern matching. Okay, so let's comment out the first one, and let's go back to the console and see if it works. Yeah, it works. Okay, so far we have removed, and okay, one more. So here again, it's a pattern matching. So let's okay, let me do this real quick. So let's just now we just do this. So the file, okay, so the file, yeah, so okay, that's it. So now you don't use pattern matching. Oh, but I forgot the original. So where's the original? So you can see here's the original. Okay, so this this part with pattern matching with a file, we don't have it here now. We just change it to a function here. Okay. And another thing interesting about Wolfram language is that you see typically in programming languages you have like the indentation, right? This is typical, very typical how you do programming. You need to indent, you need to indent correctly in order to see. That's not idiom. That's not how you do things in Wolfram language. Actually, you need a semicolon here. Okay, so you need a semicolon. That's necessary. Okay. So the way you do, typically you do in Wolfram language is like this, one single line. Okay. Now, if you copy this in Wolfram notebook, it format for you automatically. So if your window is wide, it's one, if it format for you automatically. If your window is short, it format this way with indentation or that. If your window is wide, it should format this way. And it adds a line break here. Why? Because the semicolon. Okay, there's another thing interesting. What is the thing with semicolon? Let me explain. Remember, Wolfram language, everything is this form, okay? Everything, every expression is purely this form, nothing else. Comma, square brackets, and English letters. So what the fuck is semicolon? Let me explain. So whenever you have semicolon, A, B, or C, okay? Whenever you have that, let's simplify. Let's just say A and B, okay? A semicolon B. Whenever that occurs, where A and B is any arbitrary long expression, can be 1,000 lines, okay? So whenever you have that, that's a short syntax for this, okay? That's the short syntax for this, okay? So you see, A semicolon B, that is actually the short syntax for this function, compound expression. And what does that mean? That is the same as Lisp's PROGN. That means okay, evaluate all the arguments. Okay, so let me show this here. Okay, so if you have A, B, and C, so if you have A, B, and C, that just means that, okay? So whenever you have a compound expression, that means evaluate each of the argument, but return only the last argument. Okay, that's what it means. So semicolon A, A semicolon B just means evaluate both, but return only B. Do not return, anything, about A. So if we look at the expression here, the if, okay, so, just like Lisp is often used in if. Okay. So for example, this is too long. Okay, so anyway, so my point is, if you have A, B, C, right? This is a if expression. A is test, B is what you return if true, C is what you return if false. So, but what if your B is a lot of complicated things? So that's when you do B1 semicolon B2 semicolon B3 and so on. So in same thing with Lisp. Same thing with what? For example, equal 3, 4. You see that prog n. That means if you do, if you need, let's say, message, print this, and if you have more than one message, print that, make it prettify. So you see the prog is it's like C's curly braces. It groups a bunch of expressions into one and returns only the value of the last expression. So so in Wolfram language, it's the same. It's almost exactly the same. You see, that's why I say Wolfram language is based on Lisp and APL. It's essentially a Lisp with a different syntax and meta expression. So okay, so let's go back to so that's about this if. So that's about the semicolon. Again, the semicolon is just compound expression. Now, another thing interesting to notice is that in Lisp, for example, you have now we are looking at the naming of functions, different philosophy of how you name functions. So in Lisp, in general, in Lisp, they usually name their functions fully, but still, in some cases, you have like mysterious function names like PROGN, that kind of stand for program, like program end. n programs, But in Wolfram language, they also fully name their function, but actually more expressive. So by looking at the function name compound expression, you know what it does, So it goes, Wolfram language goes one step beyond the full naming, full naming of function names, even beyond Lisp. Lisp is pretty full name, as compared to, for example, Python or C. C is the worst. C is the worst. Unix fuck. Like cryptic names, like you don't know what they're doing. But in Wolfram language, if you know the function name, you know what it does, almost. Okay, so that's a digression about the shorthand syntax, which is very important. Okay, so let's remove that. Okay, so now we back to the code, the whole thing. So now we don't have pattern matching anymore. Let's remove that. So we have rewritten the whole code without any pattern matching. So let's run it one last time to see if it works. It works. So okay. But how does this code work? We haven't explained the whole thing, but how does it work? Let me explain, okay? Given the path and a string pattern, print open every file in the print if the file content contains the pattern, print the line that occur, and print a line number in front. Okay, that's essentially what the whole program does. So first of all, you have the pattern, which is the argument, the path, the directory root path. Then this add indices function add the line number, basically. First of all, it add line number to a list. Then here is the lines. You given a text file, you split it into a list of lines. So that's what this function does, lines. The match lines is another function. Given a giant string, which is the content of the text file, it select certain lines. Okay, then here's a print lines function, then the whole thing, then print if match, then basically at the end you have file system. So let's press one key and see the documentation for file system scan. File system scan is basically a map. Okay, so it takes two arguments. The first argument is a function, the second argument is a file path. So it will apply the function to every file in the file path. So that's what it does. So it applies the print match function to every file in the given path. Then what does print match do? Print match uses all the functions before to basically print lines with the line number. Okay, but the whole thing can be done in just two lines, okay? Except, with this, the help documentation, that's one line. Then basically the rest is one single line. And it would be much more efficient. We can actually test the efficiency by measuring the time, by trying a different directory with thousands of files, but we are not going to do that. So it's now 7 minutes. Okay, so now what we're gonna do? So we can either stop now, or I can try to create the optimized version. So let's see what's the comments. Hi, Huang Nguyen. Huang, are you the Huang I know? Hey, more coffee. So I'm drinking power drink, energy drink. So Dion says, is it realistic to have eLisp functions run Wolfram programs? That depends on what you mean. But right now, this is a Emacs list function that runs this program. So, for example, if you look at the the ping window, so I'm going to call the command. Okay, yeah, let me show you how this works. Let's open a new file. Okay, so new file, save it. Let's save it. Okay, save it xx.wl. Okay, so now let's say 1 plus 3 plus 2. Okay, so let's do something more fancy. Okay, A B C. Okay, let's say map. So I'm gonna do something fancy. Okay, so that I'm gonna write a lambda, add 1, then map that lambda to this list. Okay, so this should return a list A plus 1, B plus 1, C plus 1 symbolically. That's the point. That's another very unusual characteristics of Wolfram language. So we are applying a function which add 1 to the argument and we map that function to a list ABC symbols. They are not numbers. So we should get the result A plus 1, B plus 1, C plus 1 as a list. Okay, so now we run the code. So now this is invalid syntax in order in what? Oh yeah, so that typo. Okay, so this should be a add sign /add. Yeah, so run it. So this is all in Emacs. So you can see the output at the bottom. Can you magnify the output? Okay, so so we need to show the output. So you can see the output is here. So you can see this is interesting. Okay, so let's show this in the Wolfram notebook, because so you see in other languages you cannot do this. By the way, let me just show you the full form. Okay, so this full form and meta syntax, meta expression is very interesting. So I explained that throughout this video, but let me do it one more time. Okay, so the full form for the above is like this. Okay, map 2 arguments. The second argument is a function. I mean, it's a list. Okay, so list. Okay, so this part, list ABC, is equivalent to that thing. Okay, so now the first part is the function. Okay, so the function again, a list, 1 argument x, and here you just say x plus. That's a full form for the plus sign, x1. So you see this line is 100% syntactically equivalent to the first line, because when Wolfram language sees the first line, the first thing it does is to transform it to the full form, which is what you see here. So you can understand the whole thing very clear. So map takes two functions. The first function is takes 2 arguments. The first one is a function, the second one is a list. Okay, so now if we run the code, you'll compute it twice. Okay, so you can see it returns that twice. And if we change this to 3, 4, 5 and run it, you can see the answer 4, 5, 6. Okay, so that's the power of symbolic computation. Now, in most languages, you cannot add 1 to A, B, C. You'll say, oh, A is not defined, error, B is not defined, C is not defined. So this is symbolic. So let me show you the power of pattern matching. So let's see. So let's say I have this expression. I want to replace A by 1, B by 2, C by 3. Let's say. Okay. So how you do that? You can do it this way. Okay. So this is A by 1, B by 2, C by 3. Okay, let's replace C by pi over 4. Okay, run it. Fantastic, the power of symbolic computation. Now it's pity, you see Wolfram language and Lisp is also symbolic, but can Lisp do this? No. Lisp, that's one of my complaints about Lispers. These phonetics, they could easily do all these, but they don't listen. First of all, Wolfram language is not open source, so that immediately shut off Wolfram language in front of these open source phonetics eyes. Like, they don't see it. They are blind to it because they only stick with open source. They heard, Wolfram language. Xa says Wolfram language is fantastic. Oh, but it's not open source. Oh shit! They are not gonna, they don't want to hear anything about it. So they put a blindfold to their eyes. They don't know nothing. They stick with Linux and Bash. So now you got this symbolic expression, and also let's replace pi by pi squared. Okay, I mean by square root of pi. Okay, do it. You see, now you are seeing typesetting, not the tech and LaTeX, / curly quotes, crap. It's automated typesetting you are looking at. Now, if you want the numerical result, by the way, the percentage sign is a shorthand for, okay, let me show you another shortcut, okay? So percentage sign 1 is shorthand, syntax shorthand for output 1, okay? So these two are exactly identical, okay? That means the last output, so let me run it, okay? Percentage 1 or percentage is the same thing. So that means the last output. Now we apply again a shortcut. We talked about /n. So what does / means? That's a postfix notation. That's just the same like the Unix pipe. Okay, n means numerical. Give a numerical result. So you got that. So the full form, if you want to run the full thing, what you can do is this. Okay, so that's what you do. So let me copy. Let me run it. So run it, same thing, okay? Oh yeah, why do I run it twice? Because I wanted to show you the input form. So you can type that and look at, you can see press a button, you have the standard form. Press the button, you have the input form. Well, actually input form, yeah. And let me show you another form, okay? So you have that expression. You want to say hold, then you want to say full form. So we've been talking full form all this while. So now you can actually see the full form. You see the purely nested syntax. You don't have like, what is a slash? What is this // What is this plus sign? That's not the fully nested brackets. So, but you say full form, you get these completely nested brackets. Just okay. I think I'm gonna stop now. There's no phi. So Emacs and Wolfram language can only communicate via shell process. Okay. So the way back to that question. So you see, I can run this by pressing two keys. So the actual command is this one: xa run Wolfram script print all. So so let's in Emacs, let's say describe key, and let's show the function. So here is the function, the documentation for the xa run Wolfram script print all. So it's in xa Wolfram mod. Let's go to the definition. So here is the definition of xa run Wolfram script print all, and it basically called xa Wolfram script. It just called the function xa run Wolfram script, the Emacs function, with the argument print all. Okay, print all is feed to the Wolfram script. Because when you run a file in a console, sometimes you want to print out the result, sometimes you don't. So anyway, so this XAR run Wolfram script print all is a wrapper to XAR Wolfram script with the additional option, print all expressions in the file. So if we go to the Wolfram script definition, here is a code, just like 20 lines of Emacs Lisp. So basically it's calling a shell command, not complicated. So it's at the end, this is the gist, okay? So Emacs function shell command then gives the command string, which is exactly, basically like this. Wolfram script, then dash file, then whatever the script name in the buffer, then possibly options. Actually, I don't support options. Anyway, so this is how Emacs can call Wolfram language via shell. And you can also get the output, of course. For example, if I do, I don't have it. Well, I don't have it written that way, but you can have Emacs return the output, like print, paste it here if you want to. So one way to communicate with Wolfram language in Emacs is via shell, and then you call Wolfram script basically. Now that's not the only way. The way Wolfram language works is that whenever, doesn't matter it's Mathematica or Wolfram script or Wolfram engine, doesn't matter what. Basically there's an engine called kernel, Wolfram Mathematica kernel or Wolfram engine that actually does the computation. Then you have things such as Wolfram script or front end that talks to it, even in a notebook. So the notebook, for example, when I run some expression, it's actually sending the input to the Wolfram engine. In this case, it's Wolfram kernel. So anyway, so the way Wolfram language works is that you have the engine or kernel, and you have the front end. The front end can be a notebook or the Wolfram script, whatever. So whenever you do computation, it sends the input to the Wolfram kernel. Then the kernel responds like a server. Okay, so the kernel can be remote or local. In my case, it's local, but it can be remote. For example, you can see here start kernel, local, or it can be remote. If you buy Wolfram Cloud, and you can also create kernel. You can also connect to multiple kernels, like connect to like parallel computation, like Wolfram has that. If you are a scientist, if you are NASA designing rockets, you can have things run in 1,000 kernels, things like that. Okay, so the way Wolfram language works is that there's a kernel, there's a front end, or whatever the interface. So they talk via a protocol called used to called MathLink, but now it's called Wolfram Language Protocol or something. So if I want to, I can make my Emacs, like I can call Wolfram language functions within Emacs without using the shell, without going through the shell or Wolfram script. I can talk to the Wolfram kernel directly. So that's so let's show. Okay, so the old name is MathLink. Okay, so but now. Okay, the old name is MathLink, but now they call Wolfram Language Protocol, I think. That's the protocol for, there, WSTP. Wolfram Symbolic Transfer Protocol. Very marketing friendly. Wolfram Symbolic Transfer Protocol. So you can see it supports C, C++, it supports, Java, .NET, Microsoft.NET, so I can do that, if I want to, if I really want a nice, robust interface, I can do that. But shell is good enough. So they also have WSP services and clients. Wolfram Engine, Wolfram Server, Wolfram Desktop, Notebook, and Wolfram Cloud, and so on. Okay, I think that's it. Yeah. So I think we talked long. We can actually, the whole thing, this script can be made into, George is gonna be pissed tomorrow. He says, that's how you did 1 hour video. You did 2 hours, but you didn't improve my program. But okay. Next time, But tomorrow, I think I'm gonna try to do something else, some Emac list, because yesterday it's also Wolfram language. In the past few videos, it's all Wolfram language. So tomorrow, or I'm gonna try to do something Emacs. Let's go back to Emac list. So another day, I'm gonna try to do this, but maybe I'm just doing this for fun. So thank you guys for watching. Any more questions? 2 more minutes, we shut down. Yeah, so if I'm to write a in Emac list, if I try to write communication with Wolfram symbolic transfer protocol, it'll be involved. It's not gonna be trivial. It's not gonna. I need to. Maybe if they, I don't know. Well, I'm not gonna do it. Right now it works with. Why do I have? I don't need it. I don't need it right now. But this is the real. I mean, if you really want to do something serious, for example, if some company out there want to hire me, give me a few $1,000. I'll write this. I'll write this in Emac list, or by the way, in Python for you people who are using Python or Ruby, there's already written. Okay, so for example, Python Julia, or there's already people have written using to allow Python, Ruby, or C to communicate with Wolfram language. There's already, for example, what's a notebook? What's Julia, right? Julia notebook. Let's see. I'm confusing with the language Julia. Not Julia. What's the Pluto? No, not Pluto. What's Ian? Hey, Ian Covio. Did I miss any questions? Yeah, that's it for today. So bye, guys. If you like my stuff, okay, you can donate. Buy my Emacs tutorial. Buy my Wolfram mod for Emacs, and other things. PayPal or Patreon. Jupyter. Okay, Jupyter. There it is. So Jupyter. So Jupyter notebook. Actually, we want the Jupyter and Mathematica interface. Yeah, so there you go. So you go to this is Wolfram Research's GitHub. So Wolfram language kernel for Jupyter notebooks. So let me mention one more time, okay? So you go to Xali, Xacode, Xali.info. You go to Wolfram language. Then this is my past videos. Then you download Wolfram language for free. Then you can learn about the difference between Wolfram language, Mathematica, Wolfram engine, what Wolfram script, kind of confusing. You can learn what they are. Then, if you download Wolfram engine, it's a freebie. It comes with Wolfram script, like this, what we have been using today. But it does not support graphics. I didn't show any graphics today, but it doesn't, yeah, let me show you one more thing, okay, about Wolfram script. So Wolfram script, you can say integrate, okay, so integrate x over 2, x, okay, so enter. So you can see it supports typesetting, but in a CD ASCII way. So let's do something more complex, expand. So this is, right now we are doing mathematics. X squared y third power. Okay, so you expand the whole thing to 3. Let's run it. You see, so actually, so can we do this? Yeah, let's add some pi and fancy stuff. Let's square root pi. Let's see what we got. So you got this fancy, kind of CD ASCII typesetting. But if you do, but if you have this in Wolfram notebook, then it's pretty. Let's shrink. So you see, you got this pretty. Again, it's automatic formatting. You see, depending on window width, and it's fantastic. Okay, it beats the fucking tech and LaTeX, the tech geekers of the Unix school. And you don't have to learn all the syntax, the backslash, whatever. And so what is my point? So so you download Wolfram engine. It comes with Wolfram script. Then you get this, which is not so nice, but you can install. You go install Julia. You go install Julia notebook. Then you install, you look around. They have a documentation. You install the interface. Then you can display graphics in Julia notebook. Yeah. Okay. Bye, guys.